Okay, this problem is going to be solved using Pythagorean theorem because they've indicated that we have a right triangle and we're given two sides of the triangle. We have to find the third. Since drawn on the pond here, it's a little bit hard to see. I redrew essentially the same triangle, so it's just a little bit easier to look at. Let's go ahead and solve this using Pythagorean theorem. Provided you have a right triangle, then you know that side A squared, the length of side A squared plus the length of side B squared is equal to the length of side C. A and B, those are the legs. C is always the longest side, which we call the hypotenuse. Okay, so we'll plug in the values that we have. For A, we'll use 75. B, that's our unknown, so we'll just have x squared. And then C is 90. 75 squared, I have to crank that out. So 5 times 5. Times 5. And we end up with 5,625 plus x squared is equal to 9 squared is 81, and we just have to essentially tack on the two zeros. I'm sort of taking a shortcut there. Now we want to solve for x. All right, so we've got x squared. It's a bit of a problem, but first thing we're going to do is get rid of 5,625. So we'll subtract that from each side. That's a 0, so we have x squared is equal to 2,475. In our course, we're not allowed to use calculators, so the way we should be solving this is you use the opposite operation. You take the square root of each side, and then you see if you can simplify the radicand, or the number underneath the radical. Okay, the square root of x squared is x. For 2,475, I know it's divisible by 25. I'm going to rewrite this, still under the radical, as a product of numbers, and hopefully somewhere in there is a perfect square. So I know that 25 goes in there, so let's see how many times. So if I go 9 times, that'll be 225. With 22 left over, bring down my 5, and that'll be 9 times again, and that would be 225. That'd give us a 0. Well, I'll write it. So 25 times 99, and 25 is one of my candidates. But instead of saying times 99, I realized that 99 can be written as 9 times 11. So if I multiply these three together, I will get 2,475. I've simply rewritten what's underneath the radical sign. And now the square root of 25 is 5. The square root of 9 is 3. And this 11 is trapped underneath the radical. And then we would write this as x equals 15 times the square root of 11. If, however, you're noticing that you're supposed to have the answer in decimal form, I'll use a calculator here to get that, even though we're not going to be using calculators in this class. So I would accept the answer like this. In fact, that's the only way you could answer it for me. But if you're doing homework and they think you're supposed to have a calculator, you would use the square root key. So I'll hit second. That'll activate the yellow. Then I hit squared. So you can see I have a square root there. I'll try zooming in. Well, I'm not really trying to teach how to use this because you can't use it. And I know it's not in focus either. Darn it. All right, well, let's just get this done. 2475, 2475, close the parenthesis, hit enter. So upon doing our calculation, the directions tell us to round to the nearest tenth of a foot. We have 49.74, so that rounds to is approximately equal to again, this answer is the one that I expect in class. And it might look incredibly different, but the square root of 11 is a little bit bigger than 3. And 3 times 15 would be 45. So let me just mention, as far as the picture they've given you, back out a little. The picture is obviously not drawn to scale, okay? So it looks like this should be bigger than 75, but in fact it's less than 50 feet from here to here, okay? All right, and they've given us a picture, but it's kind of hard to read, so I'm just going to make a larger one that's a little bit easier to see. They say it's 22 feet and 2 feet, and that this is a right angle. Sometimes this is going to be given to you just as a word problem with no picture at all. And they say the pole is 22 feet tall. There's our pole. And then they have a guide wire that's attached 2 feet from the base of the pole. So that's where our 2 feet comes in. But anyway, it's a right angle. So we can use Pythagorean Theorem, which states that for a right triangle, if you take the length of A, square it, add it to the length of B, and square it, it is equal to the length of C, the long side, or the hypotenuse. So A squared, we'll put in our 2. For B squared, we'll put in our 22, and we'll just call this X. All right, so there's our X. That's what we're going to find. So 2 squared, we'll make fast work of that. 22 squared is going to be 484. and then we can combine these, so we get 488. And again, in class or on a test, you're not going to have a calculator, so all you can do is try to simplify that 488. All right, so you want x. This is x squared, so to get x by itself, the opposite operation is you take the square root. If you take the square root of one side, you have to take the square root of the other side. I should mention, when we're taking the square root of each side, you're supposed to include positive and negative values, but since we are talking about a distance, we disregard the negative value. We only are concerned with the positive value. Square root of x squared is x, and this 488, we're going to rewrite that as some product of numbers. Hopefully there's a perfect square lurking within that someplace. All right, so you just look at your 488 and start thinking about the numbers that make it up. So we'll look at different factor pairs. 2 times 244. That doesn't look like a perfect square. 16, 20. 3 won't go in there. 4 times 122. That's not a perfect square. 5 won't go in there. 6 won't go in either because 3 won't go in. Okay, so only I can double 4 and cut that in half. This would be 61. Still no perfect square. I mean, 4 is a perfect square, so we'll see if we can find a larger one than 4. 8, 10 won't go. 16. That's probably our perfect. We can't cut 61 in half, so we can't double the 8. In fact, 61 might be a prime. I think the best we're going to do is 4 times 122. All right. The square root of 4 is 2, and then we're left with 122 under the radical, and this is in feet. So 2 times the square root of 122 feet is the length of our wire. But again, in class or on a test, this is the answer that I expect. But in the homework, they're saying you're going to round to 1 decimal place. So you start way back up here, and we're using the calculator. Again, I'm not really trying to show how to use it, so sorry it's a little bit out of focus. So we enter, first I need the radical sign, so I'll use the yellow to get the yellow writing, and then I hit the key with a square root. Then I enter 488, close my parenthesis, and I hit enter. So they have 22.09, and that rounds, let me make this approximately equal to 22.09 rounds to 22.1 feet. That's kind of hard to read. I think I'll write that out a little more clearly. 22.09. If I'm rounding to the tenths place, I look at that digit, we're going to round up. So that's 22.1, 22 and 1/10 feet. All right. So that's the answer they want in the homework.